So we'll discuss question number 4 in this video. So question number 4 is, consider the following statement. Relative compaction is not the same as relative density. So statement 1 is statement 1 statement 1 is relative density. See, relative relative density is equal to gamma tri gamma tri achieved in field divided by gamma tri uh, from the Proctor test. Gamma dry from the Proctor test. Proctor, that is LAF in LAF. So gamma d in field by gamma d in LAF, the ratio of these two quantity is relative density. Okay, and it will always be greater than 0, never be equal to 0, never be equal to 0. Okay, whereas relative density relative density is equal to y ratio, maximum y ratio, minus E y ratio in natural state, E divided by E max, maximum y ratio, minus E min, minimum y ratio of the soil. This is relative density. Okay, and it may be 0. It may be 0. It may be 0. So these two quantities are entirely different. Therefore, statement 1 is true. Relative compaction is not the same as relative density. So this statement is true. Now the second statement is, vibro flotation is not effective in case of highly cohesive soil. Yes, this statement is also true, because this is highly effective in case of sandy soils, and we have to achieve uh, the compaction with greater depth than this method is used. Okay, up to 30-meter depth vibro flotation is used. So in case of cohesive soil, it is not effective. So statement 2 is also true. So vibro-flotation, statement 2 is about vibro-flotation. So vibro-flotation used uses a vibratory probe vibratory probe and water jetting to settle soil, and water jetting water jetting to settle soil to settle soil particles to settle soil particles into a denser state, into a denser state. It works beautifully. It works it works beautifully on granular soil, granular slash cohesionless soils, cohesionless soil, cohesionless soil, that is sand, because the vibration easily because because the vibration because the vibration because the vibration easily rearrange rearrange easily rearrange the the grains. However, however, in highly cohesive soil, however, in highly cohesive soil, however, in highly cohesive soil like clays, like clays, the particles stick together. The particle stick together, stick together due to molecular bond, due to molecular bond, and have low permeability and have low have low permeability and have low permeability. The vibration doesn't cause them. The vibration does not cause them. The vibration does not cause them to rearrange to re to rearrange, making the process ineffective, and this making the process in making the process ineffective. Okay. So vibroprotection is not effective in highly cohesive soil. So statement 2 is also true. Statement third is zero air void line and 100% saturation line are not identical. No, these lines are identical. So this statement is false. 30% 30% air void line, air void line and 70% saturation line will not be same, but 0% air void line and 100% saturation line will be same. So statement 3 is false statement. So according to this, the answer will be 1 and 2 are correct. So answer will be A. Okay. So let me draw the graph of 0% air void line or 100% saturation line, how it will look like. So let me erase this part first. Okay. I'm explaining uh, statement 3. So in this case, graph will be like this. Suppose this is gamma dry on y-axis and water content on x-axis. So the graph will be like this. If compactive effort in this case is E1 and in this case is E2, then E2 will be greater than E1. Here E2 will be greater than E1. Okay. And this is the maximum at compactive effort E1. This will be the moisture content, optimum moisture content, OMC1. Okay. And at compactive effort E2 and at compactive effort E2, this is the optimum moisture content OMC2, and OMC2 will be less than OMC1. and corresponding dry density will be higher in case of compactive effort E2. More is the compactive effort, the higher will be the dry density, and corresponding optimum moisture content will be less. Okay, so if we join these point with red line, then this line is called, if we draw all the graph and different compacting effort, and if we join the peak of this graph, then this line is called line of optimum. This line is called line of optimum. This line is called line of optimum. And 0% air void line or 100% saturation line will look like this. Will look like this. This is what? This is 0% air void line, or it is also 100% saturation line. So statement 3 is wrong. Okay, so answer will be A. This is question all about question number 4. Now we will discuss question number 5. This is question number 5. For a given soil, the optimum moisture content increases with increase in compactive effort. Optimum moisture content increases with increase in compactive effort. No, this is wrong statement. I explained this already in question number 4. Okay, question number 4, statement 3, we already have explained this. I already have explained this. Okay, so let me draw the graph again for assertion. For assertion, if we draw the graph of dry density of gamma dry versus water content at different compactive effort. So if this graph is drawn in case of compactive effort E1, and if this graph is corresponding to compactive effort E2, and the E2 will be, E2 is greater than E1, so graph will look like this. So in this case, the in this case, when compactive effort is E1, the optimum moisture content, this is the optimum moisture content. This is the optimum moisture content. And in this case, if we say optimum moisture content 1, and in this case, this is the, when compactive effort is E2, then this will be the optimum moisture content, that is OMC2. So if E2 is greater than E1, then optimum moisture content, therefore this implies that OMC2 will be less than OMC1. So as compactive effort increases, corresponding optimum moisture content decreases. So for a given soil, the optimum moisture content increases with increase in compactive effort. No, wrong. Decrease with the increase in compactive effort will be right, but this is wrong. So this is wrong assertion. So answer will be D. Okay, if A is wrong, the answer will be D. So let me read this region. Higher the compactive effort, higher is the dry density at the same moisture content. Yes, this is true. At the same moisture content, if we take this moisture content, then at this moisture content, in this moisture content, for even compactive effort that is less than E2, the achieved gamma D is less, and in this case achieved gamma D is more. So this statement is true one, this is wrong. Okay, so answer will be D. Now question number 5. Now question number 5, 6. 5 is done. Now question number 6. So question number 6 is match roller and list to its soil type and select the correct answer. So question number 6, pneumatic roller. In case of pneumatic roller, uh, soil type will be cohesive and angular sand, angular soils, plastic soils of moderate cohesion, uh, cohesionless soils, silty soil, and low plasticity. So A, B, C, and D. In case of vibratory roller, the soil must be cohesionless. Okay, so cohesive and angular soils may be the answer for D. So this is 1. Okay, CH-4 roller is used for clay soil. So this is for cohesive soils. So plastic soils and moderate cohesions. So C may be matched with 2. And B, smooth wheeled roller, is used for cohesive plastic soil, cohesionless soils, cohesionless soils, vibratory roller, cohesionless soils. So D may be matched with 3 actually. D matched with 3, and smooth wheeled roller and pneumatic roller. So pneumatic roller in case of silty soils or low plasticity, we can go for pneumatic roller. So A 4 and B smooth wheeled roller. The remaining is 1. So smooth, cohesive and angular soils. It may be it match with 1. Okay, so 4 1 2 3. 4 4 1 2 3. Option number C. 6. Option number C. Let me check for this. C will be the answer. Not. Question number 6. C will be the answer. Okay. It will be the answer. For this type of question, uh, let me explain 446. So, question number 6. In case of smooth wheel roller, let me erase this first. In case of smooth wheel roller, smooth wheel roller, smooth wheel rollers are useful for are useful for are useful for finishing operations, finishing finishing operation. Smooth wheel rollers are useful for finishing operations after compaction of after after compaction of fills after compaction of fills after compaction of fills and for compacting and for compacting granular base granular base granular base course of highways of highways. So cohesive and granular soil is for smooth build roller. So B1. Okay, B1. This is smooth build roller. The next is pneumatic tired roller. Pneumatic tired roller. Tired pneumatic tired rollers. So these are effective for uh, effective for these are effective for cohesive as well as cohesionless soil. Cohesive cohesive as well as cohesionless soil as well as cohesionless soils compacted by compacted by combination of damping and kneading action. Damping and kneading action. Kneading, compacting and kneading action. Okay, that is pneumatic tired roller. Okay, it is suitable for cohesive as well as cohesionless soils because it has both actions like damping and kneading. Okay, so next is SIP foot roller. SIP foot foot rollers. So it is ideally suitable for are ideally suitable for ideally suitable for compaction of cohesive soil. Compaction of cohesive soils. Compaction of cohesive soil. Actually, pneumatic tire roller is are effective for cohesionless as well as cohesionless soil, cohesive soil as well as cohesionless soil, but compact by kneading action only. Okay, in pneumatic tire roller, it is not damping action. It is not damping action. Compacted by only compacted by only kneading action. Kneading compacted by only kneading action. Okay, but in case of SIP foot roller, are ideally suitable for compaction of cohesive soil, and it is compacted by combination of combination of combination of damping and kneading action. Damping and kneading in case of SIP foot rollers. Okay, now vibratory compactors. Now vibratory compactors. Vibratory compactors. Vibratory compactors are used for are used for are used for granular are used for granular soils, not for fine grained soil, not for fine grained soil. Okay, so the answer will be C. This is all about question number 6. Now we will move to question number 7. Question number 7. In a compaction test, if the compactive effort is increased, it will result in. So the same graph, same question as uh, discussed previously. So let me draw the graph again so that you can remember this by watching again and again. You can easily remember this. Okay. So if this is gamma dry and this is water content, the graph will be look like this. If this is even compactive fault and this graph is corresponds to E2 compactive fault, then in case of even compactive fault, the optimum moisture content is OMC1, and in this case, this is OMC2. Okay, so for E2 is greater than E1, this implies OMC2 will be less than OMC1. So increase in dry density and optimum moisture content. No, increase in maximum dry density, but OMC remaining unchanged. No, this is wrong, this is wrong. Next, increase in maximum dry density and decrease in OMCS. This will be the correct. Increase in maximum dry density and there is decrease in OMC. Okay, so option number C will be the correct answer. Now we will discuss question number 7. Question number 8. Question number 8. Match list 1 equipment with list 2 uses and select the correct answer using the codes given below. So vibratory roller. So vibratory roller 4 and 2, 4 and 2 to compact road and railway embankments of sandy soils. Sandy soils. Vibratory roller, yes, it may be. And 4 is to compact clay soils fields. No, this is wrong. So for A will match with 3. B, seafood rollers. It is used for clay soils. So B, for to compact clay soils, it will match with 4. C, frog hammers. So 1 is to compact confined and at corners. Yes, it will match with 1. And D, vibro flotations. Uh, D will match with railway embankments of soil 2. It will match with 2. So 3, 4, 3, 4, 1, 2. 3, 4, 1, 2. There is no any match. A is A is 4 and 2 to compact by battery roller. So A will match with 2 actually. A will match with 2 actually, and D will match with to compact confined. D will match with 3 to densify sandy soil over a large area and to large depth. Yes, D will match with 3. So 2, 4, 1, 3. 2, 4, 1, 3. C will be the answer. 8C will be the answer. So let me explain this. Question number 8. Vibratory roller. Let me remove this first. So first is vibratory roller. First is vibratory rollers. Vibratory rollers. Vibratory rollers are used to compact are used to compact granular soils. Granular soils. Okay. Safe foot roller. Safe foot rollers are used to compact cohesive soil. Are used to compact cohesive soil. Frog hammer. Frog hammer. A hand operated. A hand operated tamper. Hand operated tamper or rammer like frog hammer, like frog like frog hammer, like frog hammer is used to compact. Frog hammer used to is used to compact soils in confined area. Soils in confined soils in confined areas where other method of compaction cannot be used. Where other method of compaction is not used. Their other method of compaction cannot be used. Cannot be used. Cannot be used. Okay. Now vibrofloats. Vibro vibrofloats. Now vibrofloats are used for compacting. Are used for used for compacting thick deposit. Thick thick deposit. This is very important. Used to compact thick deposit. Thick deposit of of loose sandy soils. Sandy soils up to 30-meter depth. Up to 30-meter depth. Okay. So this is vibrofloats. This is all about this question. Question number 8. So answer will be C. Okay. Remember these points. This is very important points. These questions are uh, asked again and again in engineering service examination. Okay. So uh, very important question. Okay. So this is question number 8. Now we will discuss question number 9. Question number 9. Soil is compact. Question number 9. Soil is compacted at which one of the following when the higher compacting effort produces highest increase in dry density? So optimum water content, dry side optimum moisture content, wet side, and saturation moisture content. So the answer will be 9. The answer will be B. You can see uh, this using the graph. You can solve this problem using the graph. If you see the graph, you can directly answer this question. So this is gamma dry and this is water content. So the graph of dry density with moisture content is look like this one. So soil is compacted at which one of the following when the higher compact, this is if E1 is lower compact effort and E2 is higher compact effort, E2, this is OMC1 and this is OMC2. Okay. So if you see wet side, if you see the wet side of optimum moisture content, you see the wet side of optimum moisture content, you will achieve same compact effort. You will achieve this one increasing gamma dry A and this is B will achieve this much. Okay. And if you go beyond, uh, if you go wet side, this is dry side. This is dry side of OMC and this is wet side of OMC. You will achieve only this small a, small b. Okay. So this is wet side of OMC. So dry side of optimum moisture content uh, will give you highest increase in dry density, highest increase in dry density. Okay. So curve 1, curve 1. What is this? Lower compact effort, lower compactive effort. Curve 2 is higher compactive effort and change in gamma dry AB is much more than change in gamma dry small AB. So this is wet side, wet side of optimum, and this is dry side of. So answer will be B. Okay. This is all about question number 9. Now we will discuss question number 10. Question number 10. The clay core of earth dam is usually compacted on wet side of OMC. Yes, this is correct statement because we need a less void. We need less void in clay core of earth dam. Therefore, we go for wet side of OMC because wet side of OMC will have less void ratio as compared to dry side. Okay. So we need less void ratio in case of clay core of earth. So we will compact it in wet side of optimum. So this statement is correct. The reason is compaction on the wet side of OMC reduces permeability and prevents cracking in core. Yes, this is also correct statement and reason are explained well uh, assertion A. So answer will be A, option A. Okay. So so actually permeability on wet side optimum on wet side of optimum is less then dry side optimum less than dry side of optimum, dry side of optimum. So let me make a table. This is very important table. First column is for project, second column com compaction, water content, compaction, water content, and third column for reason. So if project is core of earth, then core of earth, then so it is compacted, wet side of optimum, wet side of optimum, and reason to reduce permeability. Reason is to reduce, reason is, reason is to reduce permeability, reduce permeability and prevent and prevents cracking in core, prevent cracking in core. And if the project is subgrade of pavement, subgrade of pavement, subgrade of pavement, then it is also compacted wet side of optimum, wet side of optimum, wet side optimum. And the reason is to limit volume change, to limit volume change. And if project is homogeneous earth dam, homogeneous earth, homogeneous earth dam, then this condition is dry side optimum, dry side of optimum. And the reason is to have a stronger soil, to have a stronger soil, to have a stronger soil, and to prevent and to and to prevent build-up of and to prevent build-up of high pore water pressure, high pore water, high pore water pressure. Okay. So the answer for question number 10 is A. So this is the table, very important table. Keep in mind. So let me make a table uh, for other properties like water deficiency, permeability, compressibility, okay, related to dry of optimum and wet of optimum. So let me make very important table. It is very important. Uh, Let me clear first this one. Hmm. So the table is like the first column is for property. First column is for property like structure after compaction, structure after compaction, water deficiency, water deficiency, water deficiency, permeability, permeability, compressibility, compressibility at low stress, at low stress, at high stress, at high stress, swelling, swelling, shrinkage, shrinkage, stress strain behavior, stress strain behavior, strain stress behavior, stress strain behavior, construction pore water pressure, construction construction pore water, construction pore water pressure, strength undrained, strength strength undrained, strength and sensitivity, and sensitivity. So this is the property, and this is dry of optimum, dry of optimum, and this is wet of optimum, wet of optimum, wet of wet of wet of optimum, wet of optimum. So in first case, in dry of optimum, the structure after compaction will be flocculated. It will be flocculated. It will be flocculated. It will be flocculated. Flocculated, that is random. Random. And in this case, wet side of optimum, it will be dispersed. It will be dispersed. Dispersed, that is oriented. And if water deficiency, dry side of optimum is high, more water deficiency, and wet side of optimum, it is less water deficiency. Permeability, dry side, it will be more isotropic, more isotropic, and permeability will be less anisotropic. Anisotropic, that is Kb is greater than Kh. Actually, Kh, horizontal permeability, will be greater than vertical permeability. And the compressibility at low stress, compressibility at low stress, uh, at low stress, it will be uh, at low stress, it will be low, and At high stress, it will be high, and at low stress, it will be higher. It will be at low stress, higher, and compressibility at high stress, at high stress, at high stress, it will be lower. At high stress, it will be lower. So this is opposite. Okay. Now at low stress, at high stress, actually, I have to write in this section compressibility, compressibility at high stress and at low stress. So at high stress, at low stress it is low, and at high stress it is high. And in this case, at low stress it is higher, and high stress it is lower. So what about slow swelling? So swelling is high in case swelling is high. Okay, drive optimum swelling is high, and the swelling is less. Swelling is low. Wet side of optimum swelling is low. Shrinkage. Shrinkage, dry side of optimum shrinkage will be low, and wet side of optimum shrinkage will be high. Okay. Stress is stress strain behavior. Stress strain behavior, that is stress strain behavior. Dry side of optimum brittle, brittle, high peak, higher elastic modulus, high peak, higher modulus of elasticity, higher E, higher modulus of elasticity. Okay, and this is ductile, ductile, no peak, no no peak, and lower elasticity of modulus, lower elasticity of modulus, elasticity of modulus. Okay, and construction pore water pressure, construction construction pore water pressure, construction pore water pressure, that is dry side low, and this will be high. Okay, and strength is dry side, strength will be high, and this is high, this is much low, and sensitivity is more on dry side optimum, and sensitivity is low on wet side of optimum. So we have discussed question number 10, and this table is very important. Just remember this table. Okay, so this is all about today. So thank you.